I'm Fiona. I'm responsible for Mod 1 Question 4B.
In Question 4b, the internal auditors of a large company are interested in the system by which incoming invoices are processed. They take a random sample of 50 complete invoices and check them in detail for correctness of procedure. 4 are found to be defective in some way. The auditors then suggest some modification to the procedure, and these are implemented. Allowing time for the clocks to adjust to the new procedure, the auditors then take a random sample of 16 complete invoices. This time, they find 3 incorrect ones. Is there any evidence at 5% level of significance that the new procedure has improved the error rate? From this question, we can see we need to test the differences between two proportions. First, let P1 be the proportion of the original procedure and P2 be the proportion of the new procedure. The sample means of the original one is 4 over 15, and the sample means of the new procedure is 3 over 16. From the formula of this, we can find the overall sample proportion is 15 plus 15 times 4 over 15 plus 16 times 3 over 16 divided by 15 plus 16, which is equal to 7 over 110. In step 1, from the question we can see that it is a one-tailed test. We assume H0 is P1 equal to P2, and H1 is P1 larger than P2. In step 2, as the level of the significance alpha is 0.05, from the normal distribution table, in 0.05, which is 1, the probability is 1.645, so the critical region is larger than 1.645. In step 3, we are carry out the test statistic set. From the formula on the right, we can calculate the set, which is 4 over 15 minus 3 over 16, divided by taking square root of 7 over 100 times 1 minus 7 over 100 times 1 over 15 plus 1 over 16. After the calculation, we found that set is equal to 0.6418. And the last step, because 0.6418 is smaller than the critical region 1.645, as a result, it is not in the critical region and H0 is not rejected. As there is a difference between the two proportions, so the new procedure has improved the error rate.
Okay, I'm Alan. Let me explain the question for C in Mod 1. In this question, H0 is mu1 minus mu2 equals to 17, and H1 is mu1 minus mu2 larger than 17. Alpha is 0.05, and we will transform mean to mu and difference of mean transform to difference of mu. In this question, difference of mean is normal because it is assumed by the question the population are normal. Okay, now we need to calculate the average difference of weights before and after, which is 19.7, and the standard deviation for the population is 4.39823196.
In this question, we are going to use t-distribution because in this question we are having small samples and the standard deviation is unknown. The alpha given in the question is 0.05, and we were going to use 0.05 in t-distribution table to find out the critical region, and the critical region is t larger than 1.812. we are going to use the test statistic formula, and the formula equals to the difference of weight before and after minus the difference of mu over the mean difference of estimated standard deviation. And in here, the mean difference of estimated standard deviation equals to the sample standard deviation over the square root of sample size. And we insert the number into the equation is equal to 19.7 minus 17 over 4.398231968 over square root of 10, and it equals to 1.94. So we reject the hypothesis 0.
I'm going to present question 4b for Mod 2. BM Group is considering opening a restaurant in a district, and the group decides to carry out a research to make sure that the restaurant will make profits. Average family income of residents in the district is believed to be a good indicator of profitability, and a level of 18,000 at least is required. The group then takes a random sample of 64 households in the district and finds an average monthly income of 17,100 and a standard deviation of 1,200. At a 0.01 level of significance, test whether the group should open the new restaurant in the district. So we can let X be the family income of residents in the district, and then mu be the average monthly income of residents in the district. The null hypothesis is mu is equal to 18,000, and the alternative hypothesis is mu is bigger than 18,000, and alpha be 0.01. Since the sample size is large, the z-test should be used. From the alternative hypothesis, we can know that it is a one-tailed test. From the standardized normal distribution table, we can know that the z0.01 is equal to 2.33, and the critical region is z is bigger than 2.33. We can now compute the value of the test statistic, and z is -6 according to the formula. Since -6 is smaller than 2.33, it is not in the critical region, so the null hypothesis is not rejected at 1% level of significance. Therefore, the group should not open the restaurant in the new district. Thank you.
I am Lo Wai Cheng Rachel. Today I will talk about the question 4C in Mod 2. Firstly, we will let X1 and X2 be the age of bias and non-bias respectively. The hypothesis is mu1 is equal to mu2, and another hypothesis is mu1 is not equal to mu2. The level of significance is 0.05. The difference of mu1 and mu2 is normal because according to the central limit theorem, and the n is large, so it is normal. And we will assume sigma 1 is equal to sigma 2, and it is unknown. In this question, the degree of freedom is 38 because it is n1 plus n2 minus 2. So it is 20 plus 20 minus 2, it is 38. In the biased population, n1 is equal to 20, and the mu1 is equals to 39.8. The standard deviation 1 is 10.0399, while in the non-biased population, n2 is equals to 20, mu2 is equals to 47.2. The standard deviation 2 is equals to 13.6211. According to the t-table, the critical region in this question is t is smaller than negative 2.021 and t is larger than 2.021. According to the formula given, we can first calculate the value of SP square, which is 143.1084, and then we can just substitute the values into the formula. The mu1 and mu2 is 39.8 and 47.2 respectively, with the difference of mean is 0, and the SP square is 143.1084 and divide 20. And so we can have the t value as negative 1.95. So the conclusion is we will not reject the hypothesis and conclude that mu1 is equal to mu2.
Question 5a. A management training program is organized by a company to teach supervisory skills. The participants attempt the exam before and after the training program with higher scores representing better supervisory skills. A random sample of 10 supervisors is selected and exam scores are shown below. Test whether the management training program is effective in improving supervisory at 5% level of significance. State the assumption. Take 70 percentile as an example. Pretest the 7th term and the 8th term. And the percentage change which is 5 point. Therefore, the answer is yes.